Hello again. I wanted to give a couple more examples of domain and range with these two functions listed. For the first one, f of x equals 1 over x minus 2, I've given you a little bit of a table of values, and I've put those values up so far, except we have this little weird one here. At x equals 2, f of x is undefined. What that does is actually gives us a vertical asymptote right through x equals 2, like so. And what that simply means is that there is no value of f of x allowed along that dashed line. Now I could ask something else, and I'll just put it out there right away. What if f of x equals 0? So what if we said, what if f of x equals 0? Just to see what happens. Well, if I plug 0 in, then I get 0 equals 1 over x minus 2. Now that's a little bit strange, obviously, because if I multiply both sides of this equation, by x minus 2, then what I end up with is 0 equals 1. Okay. This is obviously not possible. In fact, 0 does not equal 1. So what this means is we have a horizontal asymptote as well, right along 0, right along f of x or y equals 0. Okay, and so I'll put that as there, right there. We've got two asymptotes, a vertical and a horizontal. Those are untouchable places. Now let's see what else happens. If you start to put in a few more values of x to determine a few more values of f of x. Let me just put in a couple more. There's one right there. There's one right there. And it makes the shape kind of like this. And it's just going to keep going like that. Keeps getting smaller towards 0. This one keeps getting larger, but it never touches this line at x equals 2. But it goes to infinity as it gets close to x equals 2 from the right side. Now the other one kind of goes down, and it keeps going down like that. And over here goes like that. So this has interesting behavior also. If we're approaching 2 from the left side, the value of f of x just keeps going down towards negative infinity. And I think I'm going to get in trouble with my other graph here maybe, so let me erase part of this. But the whole idea is to take a look at the trend. Over here, as I'm going towards negative infinity with x, this keeps getting closer and closer to 0. That is, f of x keeps getting closer and closer to 0, but never touches it. And that's because we have this horizontal asymptote right here. So let me ask you then, what is the domain and the range? Let me just erase some of my stuff here to state the domain and the range. Take out my table. Okay. So how about domain? Those are all the x values that this function works with. So it looks like we can go all the way out to negative infinity. We can come in from negative infinity, but then we're stuck at 2. We're not allowed to hit 2. So how do we say coming in from negative infinity but not hitting 2? We say it like this. Infinity never counts. We can't include it, nor can we include negative infinity, because it's more of an idea instead of a number. Ooh, that's a terrible infinity sign. Okay. That's a little better. Okay, so we're coming in from negative infinity. This is a parenthesis instead of a bracket because we do not include negative infinity, and then I'll put a comma. And we go all the way up to 2, but we cannot include that, so I put another parenthesis. Now, we can go on the opposite side of 2. So there's another part of the domain, and I'm going to have to unite it with my first part of the domain. So the other part of the domain is anything after 2. And I put a parenthesis there to say not including 2, but anything after counts. And I'll put a comma there. And it goes on to infinity the other direction, again, not including infinity. So we're really uniting a couple domains here and collectively calling the entire thing the domain. Now what about their range? Okay. The range is essentially all the allowed values of f of x here. So if I'm starting at 0 and I look at the left side of this picture, on the left side of 2, it looks like it kind of gets close to 0 over here, and it'll get ever closer to 0. Then it goes down to negative infinity over there. Okay, so let me write that. Let's say we've got, it never actually hits 0. Goes down towards negative infinity. And never hits negative infinity, because that's an idea of just keeping on going. Okay, let me go on the other side of 2. Wow, well this goes all the way up to infinity this way. It goes out to 0 that way. So I'm going to use another one of these uniting symbols, the union. And let's say it this way, that it goes from 0, but not including 0, all the way up to infinity, of course, not including infinity. So there's the domain and the range. Essentially, the domain was everything but 2. The range was everything but 0. That's another way to say that. Simpler way, I suppose. OK, now let's take a look at our second function. This is called a stepwise function because it's defined for different domains of x. Okay, so it's -1 all the time for this interval, and then 2 for this interval, and then 5 for this interval, and I haven't defined any other part of the function. So let's check out what this looks like. Remember, when f of x equals a constant number, it's just a line, a horizontal line. In this case, going through -1. It looks like I'm going to have to pummel into some of my numbers here. I didn't do a graph so well. So f of x equals -1 from -4 to 2, including 4, not including 2. Now, I don't want to pummel some of my x numbers here because I want a nice pretty graph, so I'm going to erase my x numbers. And I think that's OK. We all understand that they're going in steps of 1. OK, so -1 from 4 and including 4. So I'm going to put a solid dot here and go all the way to -2. And then I'm going to put an open circle. The open circle means I can't quite get to -2. Everything up to that, but can't quite get to it. There's f of x equals -1. F of x equals 2 is here, and I'm starting at -2. So I'm going to put a solid dot there. And that's valid all the way till x equals 0, but not including 0. So I put an open circle here at x equals 0. Then f of x equals 5, starting at x equals 0, including 0, and out to 2, but not including 2, so I put, again, the open circle. So this stepwise function, we can actually say it continues. It's continuous from here to here because at the moment that it's open here, it's closed here. And at a moment it's open here, it's closed here, and so on. And let's talk about then the domain and the range. I called it continuous. That's an interesting word. That means as far as the domain is considered, starting at -4, it never really stopped until it got to 2, and then it didn't include 2. But it was continuous. I don't have to use one of these uniting symbols, the union symbol. So I'm going to say it started out including -4. And it went all the way to 2, but did not include that, so I'll use the parenthesis. The bracket is including, the parenthesis is not including. That's the domain. How about the range? Range. OK. Well, that's interesting. It looks like it goes from -1 to 5, but it's piecewise. So maybe I'm just going to use a set and say -1, comma 2, comma 5, and we'll call that the range. So I hope this has been instructive. Thanks for watching.